Hardware is hard. It's right down there in the name. When virtualization appeared on the scene, one of the things that it highlighted was just how hard working with hardware is. The massive public clouds have made incredible advancements in the automation and configuration of their data center to overcome the challenges of hardware and working at scale. How can those advancements and lessons learned be applied to your local data center, and what would a modernized on-premise data center using those principles look like? Hey everyone, welcome to the Anexipod, the official podcast for Anexinet. This is episode 24, recorded January 8th, 2018. I'm your host, Ned Bellavance, Director of Cloud Solutions at Anexinet, and here on the Anexipod, we talk technology for the enterprise, covering infrastructure, app dev, analytics, and anything else that is shiny. On this episode, we are going to be diving into the modern data center and immutable infrastructure with Rob Hirschfeld, CEO of RackN. Welcome to the show, Rob.
Well, Ned, thanks. It's great to be here.
Yeah, before we dive too far down the rabbit hole, Rob, why don't you tell our listeners a little bit about yourself and what you do?
So my name's Rob Hirschfeld. I've been in the technology virtualization data center business for quite some time, both in startups, and then I did a stint at Dell. I've been really involved in open source technologies. I was on the board of the OpenStack Foundation for multiple years as a founding board member, and then left that to get very involved in the Kubernetes and the open source community Kubernetes stint there. And for the last 8 years, we've been working on open source physical provisioning and automation software. Something that's now called Digital Rebar is a project my team founded. I'm CEO and co-founder of a company called RackN, and sort of Digital Rebar is our open source core of that infrastructure. It's something based on work that we started at Dell as part of the OpenStack community called Crowbar. If people want to go way back in time and hear about sort of the origins for that.
Right. Okay. As I alluded to in the introduction, virtualization and cloud have shown how simple provisioning can be for a person. We talk about spinning up resources in minutes or seconds in the case of like containers. And that's great, but before all that can happen, someone needs to provision that physical hardware. So why does that seem so much harder?
Oh boy, physical's hard because there's so much heterogeneity in it. When we start using virtual machines or containers, they're by design one thing, right? Virtual machines are very consistent. They have one set of BIOS, one set of RAID. They have API-driven control mechanisms to add disks or networking or power. And then for hardware, it's not that simple, right? You have to deal with RAID controllers and network cards, and you have to know which physical interface you're connected to turn networking on and off. And all those things are a mess because there's no consistency, right? Even the people we talk to in their own data centers, they have variations in vendor or brand or network topology. And then you cross to another data center, another customer, and they have a totally different layout, different IP schemes, naming schemes. They have different wiring strategies. They want to use, VLANs instead of multiple NICs. And so those variations are hard. It's not the hardware, right? It's not the silicon that makes it necessarily hard.
Right.
But it's the variations, and they're not bad. A lot of times we talk to people, and everybody is sort of embarrassed about their data center.
Yeah.
Oh yeah, we use this naming convention, or we shouldn't do that, or we shouldn't. And the reality is, everybody makes reasonable design decisions based on what their needs are. I don't believe in data center shaming. That said, it does cause work. So when we were doing our OpenStack first bring up days, every data center we went into, this was actually before we were doing Eucalyptus and Joyent and Azure and all sorts of other interesting deployments. And every data center was different. And so anything we wrote to automate that process ended up being one-off. And that meant that we couldn't create a community. Which now we've been working for 8 years to figure out how do you make automation that's portable across heterogeneous data centers, right? That's sort of our mantra, is making things that are portable.
Right. I mean, that's no small task, obviously, given the time frame that it's taken. And I think
it's an exponentially increasing difficulty problem. Yes.
Right, and I know exactly what you're talking about. I go into client data centers, and they do have, 8 different vendors in there, and multiple generations of that vendor, whose layout and components might be completely different from one generation to the other. And I guess that's where cloud really has a leg up. The giant public cloud vendors, they just buy 10,000 or 100,000 of the same exact server with the same exact layout, so they can have more of a homogeneity to their data center.
They do and they don't. I mean, they still are coping with variation, right? One of the things that Microsoft did very interestingly is they put in programmable chips into their NIC drivers because older generation hardware networking was not keeping up. And so they actually, make their systems more homogeneous, they have to write custom software for their NIC drivers to handle their networking requirements. It's a whole different type of scale that people think about from that perspective. But yeah, everybody has this problem. We're just hiding it. And even if you look at the clouds, if you're trying to use multiple cloud vendors, the heterogeneity is straight back in front of you again, right? The networking and authentication and APIs, they're all different. Which is the same as what you deal with on an on-premises infrastructure. In some ways, it's even harder because you have less control.
Yeah, one of the things that I deal with on a day-to-day basis is AWS, Azure, and GCP, and trying to sort of translate for clients between those three and say, well, it's called this and this, and it's called this and that, and then finding a tool they can use to kind of tie all those clouds together. And we're big fans of Terraform at Anexinet because that helps us out a lot.
Yeah, but Terraform has no abstractions. Terraform is a tool that you can use on multiple clouds, but it doesn't have a way to say, deal with a machine in 6 different clouds. You still have to have different plans for different clouds.
Right. It's one tool, but you still don't have I just need a VM and spawn it up in whatever cloud, and here's the config, go.
Right.
And
writing a plan generator is actually a fail pattern in my experience. I know there's probably everybody listening to this is like, well, I just wrote a plan generator and it's awesome. It's like, yeah, it's a short-term fix for a very hard problem.
Yeah, absolutely. It seems like all the hardware vendors have their own proprietary management toolset for just their flavor. But there's been some efforts to standardize. One of them was called Project Redfish. I think it was started by HPE. But I think Dell was kind of on board with that too. Are you familiar with that?
They're on board. They're off board. They're on board. Customers are going to have to stand up and demand some consistency and homogeneity. We track all these things across multiple platforms and vendors. Our strategy, there's 2 components to it. The first one is that we declare defeat. in trying to homogenize standards. So when we design data center automation, we start with the assumption that there will not be one consistent API or protocol. And that actually it's horrible, but it's also liberating. Because then you can sit down and say, oh, well, wait a second. If I'm not expecting a standard to emerge, then I actually have to build defensively around the fact that there's multiple standards. And that has actually worked very well for us. And what it does architecturally is it drives a lot of composability. So when you look at anything Racken's done, it is incredibly composable. So we deal with every piece of automation we do breaks into smaller and smaller pieces, and then those pieces can be reused even if a classic example for this, a little bit to Redfish's point, and I'll explain why I think Redfish is not necessarily the final solution, because there is no final solution, but most hardware vendors use the same RAID controller chip providers. They don't all do it, but a lot of them do. So if we write RAID control infrastructure, there's really 2 or 3 patterns that we have to follow, no matter which hardware vendor is doing it or if it's open source hardware or not. RAID's pretty consistent, but every vendor then wraps it a different way and exposes it a different way. Right. But we can reuse our RAID control software even if the Dell, HP, Supermicro control mechanisms have a whole bunch of different paths to get to that same composable RAID infrastructure. So for us, that's the strategy we use. So we decompose, and then we try to reuse the composable units. The places where something like Redfish is a little bit trickier is that you end up with a single API that doesn't decompose very easily. And so while you can get sort of least common denominator flavors for Redfish, nobody expects their vendors to then implement all of the details the same underneath the covers. And so there still will be variance. There'll still be some snowflaking that occurs because you have to. A vendor who has an advantage in a certain type of control mechanisms or wants to expose new hardware controls needs to be able to do that. And they need to be able to do it across their line where there's different capabilities, or where they've added a new feature and they want to expose that feature. And so it's normal from that perspective. That to me is where not the protocol piece on the server, but the management piece that the vendors are putting together typically falls down. They build management for their infrastructure, and then it doesn't translate into something that's automatable. It doesn't translate into something that's cross-vendor very well. Because they have no real incentives.
Yeah, that's the pain point that we run into with clients the most is they may have a management software for HPE, but that doesn't really snap into their Cisco UCS servers or some Dell servers that they bought at some point. So it's hard to find an overarching one that actually works well with all of them. I think it's interesting you mentioned that for the RAID controller, there's really only one or two manufacturers that make that RAID controller, and then all the different hardware vendors buy from them. And I think that's true of most of the components on the system board now. There's really only one or two vendors that make hard drives anymore. There's only one or two that make memory chips, and maybe they're rebranded, but a lot of the time you're still working with one or two variants, right?
That's right. Yeah, and that's where the composability works out really well, is that you can deal with things like that. And so a lot of times patterns that work fine generally. The thing I like to describe with this, though, is that it's sort of an 80-20 rule, right? 80% of things are the same across different vendors, but unfortunately, the 20% that's different isn't comfortably nested at the top. It's a mixed drink. It's not layered. And so what you might find is that even though the RAID controllers are the same, there's a step that you have to do that's different around them. And so that 20% is not in an easy to manage place. In some ways, cloud helps with that, but on physical infrastructure, your variation is distributed throughout your infrastructure, and so you can't build a pattern where I take 80% of my code and I lift it uniformly, machine to machine to machine. You're lifting 80% of your code, but it's 10%, then a variation, then 10%, and a variation, then 30%, and then a variation, which is where the composability comes in. You have to accept that you have this mixed automation pattern.
Right. I like distributed.
And Redfish is only part of that story, right? The thing that we find is that if you're going to automate, then you have to be able to integrate across all these different boundaries.
Right. Distributed variation. I like that's a term that I might borrow from you.
Cool. Excellent.
Cool. You mentioned composable several times, and I know that's a term that I've been hearing is composable infrastructure. It seemed like that seemed more like marketing talk than anything else, but it sounds like you've got a much more grounded definition of what that is.
Oh boy, I'm glad you brought it up like that. There are vendors. I won't out anybody, that are using composable infrastructure to mean hardware that you can dynamically reconfigure. So they build a machine, or they put a VM interface on top of it, and then they're like, oh, you can create machines of any size, or you can mix and match. That's not at all what we mean. We're talking about software composability, not some hardware API that lets you pick machines with change the size of the disks dynamically. So it's super confusing, and I'm not sure there's a market for it. I'm sure there is. HCI, hardware conversion infrastructure, has all these interesting corner cases, but it's not where we think the market's going. We're much more into commodity open type platforms.
Right. Yeah. You mentioned software defined, and that's one of the things I love about cloud native stuff is so much of it is software defined and has a nice API that you can interface with. Is it possible to take those sort of software-defined infrastructure principles and apply them reliably on premises?
Oh yeah, it is. It takes some work, and your teams have to be ready to do it. Because you have to start going in and saying, I'm going to put APIs in front of infrastructure that I'm not used to having APIs for, or that I've been buying vendor tools for. Mm-hmm. But what we do with Digital Rebar is entirely designed around, I want to API drive my infrastructure like it was a cloud infrastructure, turn things on, set final target dates or target infrastructure types, get events back. It's possible to do it. It's something that has taken us a lot of time to think through the right control patterns and models and things like that to do it as flexibly as people want. Probably out of scope for this conversation, but we're on a fourth generation at this point of the infrastructure we do, and trying to find that right mix between too specific and forcing you to follow a very give you full autonomy with choice, and that's the balance. When you talk about heterogeneity, people's data centers are different enough and their tooling is different enough, right? Somebody doesn't want to be told they can't use Terraform or Chef or Puppet or Ansible. They want to use the tools that are working for them and achieve highly automated flows. And the balancing point for that is elusive. It's tricky.
Yeah. And I read an interesting thing. I think it was Gartner or IDC that basically said, put the brakes on what you think people are going to do from a public cloud migration perspective. Most companies are going to keep about 50% of their stuff in their private data centers. So plan for that. And then also they're still going to want that cloud feel, but in their data center. So are you seeing like more demand for cloud-like features in the private data centers? In the way we think about it, our best so we're really an on-premises focused company. We do hardware. Our best customers are the ones who are the best cloud users. Okay.
Which is going to sound sort of funny. So we actually look for companies that are doing really good cloud automation, DevOps, and things like that. Immutable infrastructure is a buzzword, is a keyword for us. And what we find is that the people who are successful thinking about infrastructure in a very dynamic, reprovisioning, automated way from cloud are bringing that back into the data center. And so when we look at this hybrid data center and cloud portability, the problem is not that your current data center is not cost advantaged. It really is just the way you're managing it. It's the way you're controlling it. And so we do very strongly see that people who've moved things into the cloud have learned lessons about automating infrastructure. They have good reasons, cost, control, jurisdiction. Maybe they're building a lot of edge infrastructure and they just need to be able to run retail stores or satellite locations or things like that, where they are going to continue to manage or own their infrastructure. And the big difference, what we're seeing is that they're doing it with a cloud mentality now. And that's to me the big transformation. And I agree. I think 50% or more of infrastructure is going to stay under people's control as opposed to going all the way in the cloud. But I think that their applications, workloads, and their overall IT processes are going to be much more fluid between those environments than they have been in the past.
Okay. Yeah,
that makes sense. That's sort of a big couple of concepts I lumped together.
Right. Well, let's pick one of those apart. You mentioned immutable infrastructure, and that's another term that I've heard, and I kind of think I know what it means, especially in a cloud sense. But what does immutable infrastructure mean to you?
It means that you've approached building your infrastructure, which to me is application deployments, not just the actual servers themselves, in a create, destroy, recreate, or provision, destroy, reprovision concept. So typically, in the last decade, we got really good at automated systems for patch management, reconfiguration. So what we would call day two operations. We'd install software, we'd use Chef, Puppet, Ansible, Salt, to then keep that system up to date.
Right.
That's configuration-driven systems. Immutable takes a very different strategy. What it says is, I will never patch a system. That's where the immutability. I'm not going to change it.
Right.
I'm not going to mutate it. And so instead of changing the systems, what I'm doing is I'm tearing the system all the way down, and then I'm provisioning a new instance of my application that has all of the components I need, or most of the components that I need, already configured. And then I'm rejoining that new node, that new machine, into my infrastructure. And so it's all about re-provisioning, not provision and update. And so clouds are great for that pattern. Containers are great for that pattern because they really reward you to create, destroy, recreate. And what we've seen, and I'll talk about on-premises in a minute and how that works, but what we've seen is that creates portability, security, and certainty about your infrastructure like the other pattern couldn't do. So I create a single artifact that has my operating system, its dependencies, the actual application bits, all wired together as an artifact. I can test it, and I can be certain that it's all going to work together, which is really where a lot of software deployment falls down. And I can deploy that as a unit. It's fast, it's secure. I might not even have to give SSH because I'm not going to have to reconfigure it. And then I just have to do enough post-provisioning that I can join it to a cluster, give it an identity, inject some secrets so that I can send my credentials into that. And then from that perspective, that machine isn't going to be reconfigured or touched ever. It'll just get destroyed, and then I'll bring in a new machine that has that capability. And to make all that work, it's very powerful. It's very fast. It's much easier to troubleshoot and test. And so we're seeing people get very excited about that pattern. And it's trickling down from containers because that's really how containers operate. But it's been in the cloud for a while with virtual machines and Amazon Images, AMIs. We're just getting better and better at managing that process, typically through a CI/CD pipeline. So people add in a stage in their pipeline that says, build my image. I'm sounding very like, build my image, yay. But it is, you can literally package. There's a HashiCorp has a product called Packer. There's a couple other ways to do this. That one seems really popular, where you get to the end of your pipeline, you build your application, its dependencies into an image, and then you shoot that image off to your deployment of choice. For what we do in on-premises, that's tricky.
Right.
There's no two ways to say it. You can do it by doing a traditional provision, and then doing all of your post configuration, and then just agreeing to never post configure, and that works as an immutable deployment. What we're actually starting to help people with now is actually doing image-based deployments. So you boot a temporary OS and an in-memory OS. You stream that image down to the disks. You then do some magic where you resize the disks correctly and you set the boot volumes. That's where things get tricky. And then you basically reboot the machine and the new system starts. And then from there, you then have to initialize that system using a cloud init, which works for Linux but not Windows, or some other client that can pull in this is my machine, its name, its identity. Some of that you can do during the imaging process. But for the most part, you have to run something that then injects the minimal configuration to start the system.
Right.
And that's something that Racken commercially has been prototyping with customers. We have processes that work. They're amazingly fast. They're really powerful, but they're not productized yet. So it's something we help customers with on a sort of a one-off basis.
Okay. Yeah, as you were talking, I thought about the pipeline, like a CI/CD pipeline, right before you said it. I'm like, oh, that sounds like something you could really fit well into a CI/CD pipeline. Just like as part of your, different staging efforts from dev to QA and through, knowing that you have a consistent build, not just for the application, but all the pieces that sit underneath it and support it, and that it's going to rebuild the same way every time. That just sounds like it would add so much stability to your build process and your day-to-day running operations.
It's a big deal.
Yeah.
It's now the challenge is you have to have pipelines to do it. I haven't seen anybody do it effectively with sort of a build, push a button and crank out a new image type process.
Right.
So it requires a certain degree of operational maturity for people, but it's what everybody recognizes as best practice. So it's pretty straightforward from that perspective.
Yeah, I'm curious. Yeah. What are your thoughts on if someone wanted to adopt immutable infrastructure as their process? Is there some like baby steps they could take, or small steps they kind of chip away at the monolith of what they're doing today?
I mean, CI/CD pipeline is going to be your starting point from that perspective, and then using it in cloud. So if you want to try and look at a process like this on a physical on-premises infrastructure, if you can't make it work in cloud, you're not going to make it work on things. That, and then so that's one way. The other way I would say to do it is you don't have to do it with images. So it is possible to do it using a traditional boot process, where you're treating things as a more locked box. And so you could just sort of consolidate things into, sort of a one-time configuration and destroy pattern without having to build the images.
Okay.
That's what I would call 2016 immutability on premises. Because we saw people doing that, and if you think about the hardware bugs that we're seeing, the attack vectors, just the complexity of maintaining an operating system, right? We're patching things like crazy. Then if you're not re-provisioning your infrastructure on a regular basis, sub-quarter level, maybe once a month, then you're actually going to have a lot of trouble managing that infrastructure over time because things are speeding up. So, right, the best practice for me, immutable or not, would be that somebody's looking at re-provisioning every machine in a data center on a monthly basis, or faster. It's got to make some people freak out.
Yeah, just like a little bit.
But if you don't have a process like that, then you're vulnerable to the security hacks. You're vulnerable to disaster recovery, where you don't know how to rebuild images. Where all of these things are really good hygiene. If you have servers that you haven't rebuilt in a year, and you're relying on the patch management that comes with that operating system to keep it up to date, that would make me nervous.
Yeah, I feel like really old servers, sometimes you don't know everything they do. Because this guy built it, and then this gal went and configured this application, somebody else tweaked this registry setting. If that server blows up, you have no idea how to build that back up to where it was, or even what it was doing. Right. When we try to help clients with DR, that's when they really find out how little they know about their systems, because when you try to properly execute DR, there's all these gotchas that they didn't know about and no one had documented. But if they'd been building on a regular basis, they would know a lot more about their systems and how they actually function.
And that's where you get somebody that's left SSH access open to a machine because they had to troubleshoot something in 2015, and that back door was left open, or I know why things get to be that case, and what we really want to do is help people get to a point where they are not leaving systems up, where they know how to re-provision. And then that lets them reallocate machines. It lets them confidently turn things off. There's all these operational wins from having a much higher turn rate environment that you get as sort of a side effect of this type of agility.
Right. Now, I know building the stack from scratch, it sounds very cool, but it does raise some questions like, where are your persistent items stored? And how do you handle things like a database backend that can't be quickly re-provisioned?
Oh, it's a good question. I mean, that in some ways containers have exactly the same problem with these things. So, boy, we spent some time talking about this. There's a couple approaches. One of them is that just because you're really installing the operating system doesn't mean that you're blowing away all the data that's on the system. So if the goal here is to keep the operating systems fresh, and most people doing physical will put their operating systems on a separate volume or partition than their data. Or you could even run the operating system in memory and never install it to disk if you're really into this type of immutable, network boot only approach. And so from that perspective, it's just at that point you just reattach the disks. And then the data shows up again. You have to re-inject the configuration of the system. but that's actually not that scary. With containers and VMs, in a lot of cases, you're not storing the data on those systems either. So you're attaching to a storage area network, or so a LUN, or you're attaching some file share, remote data, or some object system. And so those aren't really as scary a problem as you might have thought. If you're actually talking about the storage system itself, in that case, what you really want to be doing is having resiliency anyway. And so taking down a node and then scrubbing the disks and letting the cluster rebalance is actually part of the health of that cluster. And so in those cases, if you're building a big, maybe not a vendor-specific storage array, but if you had, say, a Ceph cluster or a object storage, like a Swift cluster or something like that, cycling a node through these systems, cleaning them all up, and then having the system rebalance is important hygiene, because otherwise you end up with data clustered together, and the rebalancing algorithms aren't run as much. So it can be a really good pattern to be doing the same process on both persistent and remote storage.
That's a bold
not the
statement,
not the answer you were expecting. It's
I wasn't sure where we were going to go with that. That's why I asked. That makes a lot of sense to me, though, especially with distributed storage systems like Ceph or like vSAN from VMware. Like, any of those single nodes can be recycled at any time. And it's interesting you say that it can actually improve the overall hygiene of the system, because you're forcing those storage algorithms to fire off and rebalance things. That's actually pretty cool.
You're effectively validating that their disaster recovery plans are always working, which is chaos monkey type thinking. If I can't handle a node going down and being rebuilt, if you lose sleep over that process, then you better start doing it on a regular basis, because right, you're like any DR strategy, right? Disaster recovery strategy. You need to make sure that it's ingrained in what your processes are doing. You don't want to be scrambling, and that's part of the idea with a lot of this immutable infrastructure, is that you're much more resilient to change because you're constantly rebuilding your infrastructure.
So your company you mentioned is RACN, and that's RACKN, the letter N, right?
It's a play on words a couple of ways, but the idea was when we came up with the name was that it's unlimited infrastructure, so the nth rack,
right?
If you will.
No, I like it. And you have an open source solution called Digital Rebar that can help with some of this sort of immutable infrastructure. I'm curious, first of all, where did the name Digital Rebar come from? Because I think it's a really spot on name.
Oh yeah, we love it too. Our CTO Greg Althouse gets the credit. We had been working on the Crowbar project, and version 2 was called Open Crowbar, and we'd reached a point where we had come so far from what that infrastructure was that we needed a new name. So because we had basically come up with the third generation from that. And it was one of those epiphanies where we were looking for a happy short name, and then what we really were happy to do is have a little bit of a bridge from Crowbar into something new. And so Rebar ended up being the sort of that breakthrough name that we were able to find, and then the appropriate GitHub repositories and things like that. There actually is another Rebar out there, which is for Erlang test infrastructure. So thus Digital Rebar. And then we've been happy with it since. And then the meaning for people who aren't immediately relating to the word rebar itself. Rebar is the steel that's used inside of concrete to make it strong. And so when you want to build a skyscraper or a strong infrastructure in the physical world, you add rebar to it, and it dramatically increases the strength and the resilience of that infrastructure. And so from that physical analogy was a perfect metaphor for the type of things that we see doing from a physical side, where if your foundation isn't solid, then everything you build on top of it is shaky. And that was our firsthand experience with OpenStack. When we were trying to build OpenStack infrastructure, if we didn't get the base laydowns right, no amount of automation on top of that would create a reliable infrastructure. And so thus Digital Rebar.
Got it. And that like I said, it really resonated with me immediately. I was like, okay, I get what that does. Good.
Awesome.
A lot of marketing terms don't do that, so that was nice to find one that did. So what is digital rebar? What are the sort of the components, and how does it assist someone with this immutable infrastructure pattern?
So digital rebar, and specifically version 3 for us, which we sometimes call digital rebar provision, and if we have time, I can talk through some of the history. The last version of digital rebar had a lot of orchestration components that we actually left on the shelf when we went to version 3. Digital rebar version 3 is a single Golang executable, so very simple multi-platform API-driven service. So cloud native physical, which is sort of fun, that handles all of the provisioning tasks that you need to bring up a physical data center. So there's a couple of protocols that have to work together to make that happen, commonly known as the PXE boot process. So you have to be able to handle DHCP, you have to be able to handle TFTP, which sends down your initial image, you have to handle HTTP to drive the actual OS, the secondary seeding of that. And then where things start getting fun is that we also have a Golang templating engine that drives a job queue system also. Very minimal, simple to use job queuing system, but can handle post-provisioning processes. So you can sort of link all of these protocols together to be able to, when a machine first boots, it gets a discovery image. That discovery image registers the system back into the APIs for digital rebar using a single-use token. And then from there, it can ask, do I have any additional post-provisioning steps that are necessary? So we have a runner that runs on the system. It's multi-architecture, so Windows or Linux. And then it'll provide an inventory. It can do burn-in. It can do all these extra tasks. And then when it's done, can literally say, turn the systems off, talk out of band management tools, reboot, and then switch over to do a regular operating system image, or inside that discovery image could immutably provision a disk image so that you could boot straight into a mutable boot. But digital rebar basically is the scaffolding, and this is where it gets sort of the rack-end rebar distinctions. So the open source digital rebar is what we would call scaffolding. So it provides the API, it provides the hooks. It's the sort of the mechanics of running all these protocols together. To do that, you have to have automation, scripting. There's templates and scripts and things like that. And all of those pieces are, some of them we maintain in the community, and some of the more advanced ones are maintained as rack-end assets, like IPMI, out-of-band management plugins, some of the operating system scripts, burn-in processes, things like that are all handled as basically downloadable content, if you want to think about it that way. We work really hard to make this very simple to use,
right.
Like 5 minutes install, 2 hours or less of a learning curve.
Wow.
Yeah, it's super. We work really hard to make it easy.
Yeah, it's funny that in order to make something so complicated easy, that's a ton of work right there.
That's why it's
I know what that feels like.
4 generations, right? The last generation, to do all that work, you had to subscribe to our orchestration models and things like that. And what we heard was people wanted the capability, but they were losing too much control. And so this new generation with digital rebar provision, we can do a lot of workflows, but in a lot of cases, people just say, get me to a running operating system and install a chef client or a salt client or my SSH keys and then get out.
Right.
And we do that. That's fine.
Yeah, I see that approach happening more and more, where tool sets are becoming more focused on doing one thing really well, as opposed to trying to boil the ocean.
Yeah,
it's
and then for us, it's about integration and chaining. So the people who are interested in what we do, the things that makes us distinct from, say, a cobbler, is that our design is entirely about integrating to a broader data center workflow.
Wow. So if someone wants to kind of get their hands on this, I know a lot of time most people don't have a fleet of bare metal servers at their disposal to try this stuff out. So what do you have to do to get the software itself running, and where could you kind of test drive it?
So, believe it or not, a laptop, MacBook is sufficient to. And this is actually a design priority for us. We test on our own laptops and desktops quite a bit, and so you can just use VirtualBox and Pixie Boot machines in VirtualBox to test it out. That's the 5-minute experience. The community website, you don't have to engage RackN at all. You can just go to rebar.digital. We have a quick start guide. Download it on your laptop and get running. The next phase after that, we use a company. We partner with a company called Packet.net, which does bare metal hosting.
Okay.
And they have the interesting feature of allowing you to run your own Pixie server. And so we can actually, Digital Rebar happily runs inside their data center, and you can boot provision your own Digital Rebar infrastructure inside of Packet, and then point your Packet hosts to that server. And it gives you actually a lot more control of the imaging and the timing and reuse of the machines. And so we recommend people experiment in Packet.net quite a bit. There's a discount code. If you've listened this far into the podcast, yay. There's a discount code, RackN100 will get you about $25 now in credit against Packet.net.
Okay, that's cool. I was going to ask if they had like a free tier or something like AWS has, but I assume since it's bare metal, they're not just going to give that away necessarily.
No, but it's $40. I mean, it's very inexpensive for metal.
Okay.
Very, very inexpensive.
That's cool. And I guess if you're lucky enough to have a few spare servers sitting in the data center that you can re-provision and test out on, you could always do that as well.
Totally easy. The biggest challenge is you have to understand your networking enough to know how what your DHCP infrastructure is.
And if someone wants to know more information about RackN or Digital Rebar, what's the best places to go and look?
So rackn.com for the website there. Rebar.digital is the Digital Rebar site. We're pretty active on Twitter for both those. RackN Go is the handle there. And of course, people can always just come to me. I'm Zehicle Online, Zehicle. I've had that handle for a long time. And so people know me there on Twitter pretty well. And I love to debate, discuss, and trash talk on Twitter all the time. So.
Okay. All right, great. And last question, I like to ask this for everyone. What is your favorite 80s movie?
Oh, my goodness. I have to make sure I'm even classifying it down into the 80s. The first one that came to mind for me was Goonies, but I think that's because I'm watching Stranger Things now, and I'm in a Goonies frame of mind with Stranger Things.
Hey, Goonies is a good pick. Don't second guess yourself.
Yeah, Goonies is great.
All right, cool. We'll go with that. Well, thank you so much for appearing on Anexipod. I very much appreciate it. If people want to know more about you, I guess they can follow you on Twitter. And is there anything else you wanted to say before we sign off?
No, Ned, it's been a pleasure talking with you. Great questions. Thank you.
And that was our show with Rob Hirschfeld. Thanks to the marketing team for helping me put this together. Thanks to Anexinet for helping me produce this podcast. If you're looking for a company to help you with your digital transformation, then I would recommend reaching out to Anexinet to see how they can help. If you've enjoyed this episode of Anexipod, why not leave a nice review on iTunes? We'd sure appreciate it. If you're looking for more content, you can check out our sister podcast, Buffer Overflow. On that show, I am joined by my co-host Chris Hayner to discuss what's new and interesting in the IT news sphere. You can find out more about me and what I'm up to on Twitter at Ned1313 or on my website, nedinthecloud.com. Thanks for tuning in, and remember, IT moves pretty fast. If you don't stop to look around once in a while, you could miss it.